I have here a first operator playing a superposition of 4 sine waves, fundamental in the harmonics. This is a parallel mode, so I'm adding every sine wave to the signal, and they are all retriggered at 0 degrees of phase, so they are all starting at 0 at the starting of the sine wave. If I move phase, you see the displacement here happening, right? But they are for the moment all at 0. So let's play that. Pure tone, first harmonic, second and third harmonic, right? Let's have a look at the oscilloscope. This is the resulting waveform coming from this sound. If I were to play another one, which is the same operator, but now what happened is that I actually changed the phase of the different harmonics, you could say that they sound pretty similar because they have the same harmonic content, but the phase of the different harmonics is not the same. So if you would look at the oscilloscope, this is the first one. This is the second one. You see the form of the resulting waveform isn't the same because of the phase alignment of the harmonics is not the same. So this is the first one and I'm showing the second one together. So you see the waveforms are not exactly the same. And this is why phase shifting is also having an effect on the transients, because it's changing the alignment. Let's check out now the impact of this phase shifting through the transient and to the color of sound. As you listened first, I was flipping between the aligned and the non-aligned. Now what I'm doing is actually playing the same chord, but the difference here is that in this instance of operator, I removed the retrigger of phase. So the first hit will start at 0 of phase, and then the oscillators will continue indefinitely to play. And we are just going to take some snapshots at different moments, which means that actually they will not always start at 0 or at the same position. The starting position will change, and this will affect the color of the sound. One of the grounding principles of analog synthesizers. And those small differences in sound bring life to sound. It's not like if you would repeat the same sample over and over again when you're playing analog, and this is what people refer to analog warmth. There is also distortion and other principles, but part of the analog sound is this fluctuating sound, and this is due to phase. Let me play you this. First, you will listen to a few notes with the retrigger on. And after a few hits, it's already boring. It's always the same. Let's turn off the retrigger of all the oscillators. And now, even if the sound globally remains the same, it's evolving through time. It's never twice exactly the same. Globally, the ear captures this as being one chord. It's the same sound, it's the same harmonic content, yet the timbre, the texture is a bit changing because of this phase aspect. If we start to play very, very, very snappy sounds. Snappy sounds mean hard transients. It's starting very steep, like this is a steep attack, this is a smooth attack. The steeper the attack, the stronger this first impact becomes, the more we will hear the difference in phase. Why? If now you're moving through time, but you are capturing snapshots at different moments, it means that instead of starting at 0, you might start at a higher point. And if you open the door, if you press a note and the VCA is opening in a very short amount of time, there is no fade. Virtually, if you have no attack time at all, 0, it should start immediately where the signal is. But this is impossible. A speaker can't go from a 0 position, from a flat position, to some movement in no time. There is a physical displacement that is needed. And this is creating a click. This is creating transients. So in this example, I have retriggered the envelopes very short attack, and you will hear all the attacks will be the same. Then I will change the retriggers, and then the texture of the different attacks will change. And this is again typical comportment from analog sound. This is why, for example, if you play kicks with an analog drum machine, every impact of the kick will sound slightly different. If you want very stable kicks, then you should record the analog drum machine and duplicate that single sample. Let's play that. Here, all the attacks are exactly the same. No difference at all. You even see the level of the peaks here that is changing. This is because phase affects the peak level, it's affecting the transients because it's affecting the working together or against each other of the different oscillators.